Welcome. This is Chuck Ridgway, Automation Technology Manager here at Horner. Thanks for joining us for another Tuesday live stream. Now this week we're going to hop aboard the Wayback Machine all the way back to 1998 for today's topic, which is Retrofitting Legacy OCS Part 1. Why 1998, you say? Well, that happened to be the year that we released the very first Horner OCS all-in-one controller, and it was a very popular product. You know, we sold thousands and thousands of them, and frankly, there's still thousands of them out there reliably controlling machines all over the world. But all good things must come to an end at some point, and probably a lot of those machines that are still running along with an OCS100 or 200, they probably should be modernized pretty soon to add some new machine capabilities for the next millennium, really. So joining me today for today's topic, as he often does, is my colleague, Mr. Casey Gardner. How you doing today, Casey?
Hey, not too bad. How's it going, Choke?
It's going pretty well. It's going pretty well. And yes, I was firsthand for the launch of the OCS back in 1998, if you were going to ask me that question. And now I will ask this question. Were you actually alive yet?
Oh, of course, of course.
Absolutely.
Just barely.
Just barely, but yes, you were alive. Okay, very good. Now, one of the things we pride ourselves on at Horner is the fact that our equipment can be retrofit really well. So why do you think that is?
Well, first of all, for these dinosaur-esque products that you have a little more experience with than I do, but really when it comes to a lot of those kind of applications, the first thing that comes to mind is does your logic carry over? And in a lot of cases, yes, in terms of the general logic behind the scenes of the controller carries over pretty well for most of our products. And really what ends up being touched up the most, especially for something like the topic we're talking about today in terms of the text-based OCSs, is really just graphic redesign, is putting some effort into modernizing graphics, whereas a lot of the others, logic behind the scenes can be easily copied and pasted or just mildly adapted into today's systems, especially using the same software, or at least a more modernized version of the same software. Kind of helps speed up that process for sure. Absolutely.
So in a lot of cases, you can really take advantage of a lot of the intellectual property from the machine instead of starting from scratch or digging up an old printout somewhere and copying the machine logic over with newer software or something like that. So definitely a topic people should be aware of if you've got Horner equipment in your plant, for sure. Now, Casey's going to be manning the chat today. We are fully live, and he is standing by to answer any questions that you might have. If you're watching this live, give us the questions in the chat section. If you're watching it on replay, give us your questions just in the comment section and we'll get those answered just as soon as we can. Okay, let's go ahead and get started. Okay, here's how we're breaking down today's topic. We're going to start with a brief history of the very first Horner OCS all-in-one controllers that were text-based units. We're going to give you a little bit of a video tour of the hardware so you can see what it looks like, get a feel for what we're talking about here. And then we're going to go through really step by step and talk about the retrofit procedure that we recommend when you're taking older controls like this from Horner and replacing them with some of our newer stuff. That procedure, of course, is going to range from acquiring the program, analyzing the I/O requirements, selecting a replacement unit, analyzing the user interface that's in place and planning really out the user interface that you want to install, making any logic changes that are required, even though you should be able to reuse a lot of the machine sequencing and a lot of the logic that already exists, just like Casey mentioned. And then, of course, the last step, at least in our list here on our retrofit procedure, is going to be to configure the new user interface. All right, let's dive right in. Okay, let's start with that history of the original Horner OCS all-in-one controllers from way back in 1998. So basically, the first Horner all-in-one controllers, OCS, were released again in 1998, and they were one of the very first on the market. We weren't the very first on the market, but we were one of the first couple or three, okay? Now, our units were character-based in those days, okay? So they were based on a text-based display, and that was for a reason. Keep keep in mind, back in the late 90s, microprocessors did not provide the type of performance that would give you fast logic scan rates as well as responsive user interface for a pixel-based display. Also, some of our competitors decided to start out with graphics units, which was their choice, but the result was that a lot of those units were really underpowered and they had really long scan rates. And we thought it was really important to provide the first all-in-one controller users with a fast scan rate as they replaced potentially a PLC in their application. Now, as I mentioned, these were text-based units, either available with a 2-line display or a 4-line display like you see on the screen there. And there were a couple different varieties of memory. There was the kind of original units, which had 2048 %R type registers, and then there was the somewhat later units that had up to 10,000 of those word type registers. Now, these units were based on an Intel microprocessor. For those of us today, we know that Intel's not a big player in embedded microprocessors, but they were back in the day, certainly back in the late 90s, and so we utilized them for this product line. Also, the backplane that was used by the original OCS, the backplane which is where the I/O basically communicated, it was a parallel backplane. And back in those days, that made it higher performance because there were a lot of serial backplanes, but they weren't as fast performing. Now today, of course, with modern architectures and modern microprocessor speeds, almost all automation-related backplanes or automation-related networks are serial in nature. But back then, it was an advantage to be parallel. Now, the first OCS units were all metal in construction. That was for a couple reasons. The first reason was that we weren't really sure how popular they would be, and tooling of plastic back in those days was ungodly expensive. And it also took a lot of time. So it wasn't something that we did with the very first generation of OCS. Now, it made for a very rugged product, which held up extremely well, but it was not the most elegant design. We'll be the first ones to point that out. When you're talking about metal fits, it was a bit of a challenge to get everything designed, but in the end, things held up really well. But again, it wasn't the most elegant design that you've ever seen. Now let's talk about the I/O element of OCS back in the day, because again, it was an all-in-one controller and built-in I/O was a big part of the equation. Now, it happened to be modular back in these days. It's stacked on the back. I'll show you that in the video tour coming up. You could have up to 4 smart stack modules on the back of every unit. There were more than 20 different models available in the family. If you wanted Ethernet, you did have to add a special Ethernet module in the first slot to support Ethernet. Also, from a networking and communication standpoint, it did support CAN. Keep in mind, this was in the relatively early days of CAN, but we at this stage had a lot of experience with some very high performance material handling applications for the US Post Office, which is where we invented CScan. And so CAN was included standard on the original OCSs, and then they also had a single RS-232 port that was used for both communications as well as programming. And one thing to keep in mind is, because Horner is so focused on supporting our OEMs, we made this product available for more than 15 years for our OEM partners, even though we had faster, newer, more elegant products available within a few years of the release of this first generation. Okay, now let's take a look at some of the hardware that we're talking about from back in the day here. What you're looking at here, and I don't have this particular one powered up, this is an OCS100. So this has a 2-line by 20 character display. Okay, it is made of metal. You probably can't tell how hefty it is through the camera, but it's definitely pretty hefty. It has, in this particular model, you had 10 keys, which doubled as numeric entry keys as well as function keys. You had arrow keys for navigation. The up and down arrows were typically used to move from screen to screen. And then, of course, you had enter, escape, and shift, as well as OK and run LEDs on the front. If we take a look at the unit on the back, we'll see pretty basic connectivity, really. 24-volt connection here. It was not wide range DC power. And we have the CAN port here, which was developed back in those days. Now, we also have, in this particular case, I have 2 SmartStack modules plugged on the back here, and you could have as many as 4 plugged on the back of any of these units. Okay, so this is the OCS100. Oh, one more thing I want to show you, and that is, here's that programming port, communications port. That's a 9-pin RS-232. Okay, now we also had a 4-line by 20 character unit. Let me show that to you here. And this particular unit I have powered up so you can see what the screen looked like. Again, very basic text-based display. With the 4-line unit, you got a little bit more text on the screen along with dedicated keys for both function keys as well as numeric entry, as well as a dedicated system button and a few other, again, more dedicated keys. So otherwise, on the back of the unit, it was effectively identical. So this is the OCS200 unit that was also available. So what we're talking about today, of course, is retrofits, where we're going to take machines running these products, and we're going to go ahead and put newer Horner controls on them. So let's head back to our slides, and let's now dive into the recommended retrofit procedure that we're going to review with you today. Okay, so the first step, how do we get started with our retrofit? Well, the first thing is really to do a really nice retrofit where we can fully take advantage of the logic that was developed, that's been running in the machine reliably for a number of years. We have to have a copy of the CSP or Cscape program, okay, the CSP file. We need to have that. So hopefully that was archived and you've got a copy of it in an archive in file form. But if not, you could choose to go ahead and upload the program from an existing unit, again, provided that the program is still in there and provided that the unit is effectively in working order. Okay, so you're going to have to get a hold of that program. Now, if you are going to upload the program, we don't recommend that you start with the latest version of Cscape. What we recommend that you do is go on the Horner website, go under Support and Cscape, and then from that page you can scroll all the way down to the Cscape Archives link, and that will bring up a page that has a whole number of really older legacy versions of Cscape. And the one we're going to recommend that you start with is Cscape 8.52b. So that is probably the best version for compatibility with the original OCS100 and 200. Now, if you attempt to upload and it tells you that the program was developed using a newer version than 8.52b, then we suggest that you download version 8.8. That's probably really the last viable version of Cscape, where the OCS100 and 200 were kind of mainstream products at that stage. So again, we recommend you use one of those 2 versions, and you shouldn't have any trouble in installing those alongside whatever new version of Cscape that you currently have. Now, if you're wondering how do I connect to the OCS, because having the right software version is one part of the application, but you need to have the right cable, of course, as well. Now, if you're currently a user of our standard OCS cable kit, then you're almost there. Now, the USB serial adapter that's included with our standard cable kit, it is pinned out properly, but you'll find that it doesn't plug in because of a mechanical interference. So really all you need to add to that kit is a 9-pin male to 9-pin female straight through adapter or something like that. Now, if that's not readily available, you can't find that anywhere, then we have a dedicated kit, which is effectively a USB to serial adapter along with the right cable. That's available as an HE500 USB 600. That's available in stock, and you can use that part number to actually make the connection between your modern computer and these older units. Okay, so let's say you go ahead and you do the upload, and you're attempting to do the upload, and the first thing that happens is up pops a password requirement. So what does that mean? Well, the first question to really ask is, does my company own the rights to this program? Am I allowed to use this logic that's in there, this intellectual property? Or maybe does the original OEM machine builder own the rights to the program? Because if they do, you're going to need to contact them on this retrofit if you want to, reuse that logic. Now, if you do own the rights to the program and you're comfortable in that, but you don't have any more, you don't have the password, then at that stage you need to contact the Horner Tech Support Department, and we will start the due diligence process to make sure that if we do move forward and help you get the program out of that equipment, that again, we're not violating anybody's intellectual property. So again, if you don't have the current password and you do own the intellectual property, contact us and we'll start our due diligence. Once we've actually got the program, whether we had to upload it or whether we already had a copy of it exactly, now we're going to want to start to examine that program. So first, what we're going to do is we're going to back up that file. We're never going to work on the original and only copy of a file. We're going to always work on a copy. And then we're going to start examining that particular program in Cscape. Now, despite what it says on the screen there, we're not quite yet going to open up that program in a newer version of Cscape. We're going to start with that 8.52 or 8.8 version first and take a look at a few things over the next few steps. Then we'll get to the point where we'll open it up in the new version of Cscape. So where we're going to start is by analyzing the I/O requirements. Why are we going to do that first? Well, the I/O requirements are a big part of any retrofit because that's a potential area where differences could be found. Certainly they almost will be found, because not only is the OCS itself, the old text-based OCS, obsolete, but so is the Smart Stack I/O that connects to it. So you're going to be replacing that with a newer I/O system, so we need to know precisely what I/O is being used with the original system. So we're going to start in the hardware configuration. We're going to take a look at what I/O has been configured in terms of the original system. We're going to dive a little deeper, and I'll show you all this in Cscape, but we're going to dive a little bit deeper and we're going to take a look at the part numbers for each of those modules, make a note of those, and we're also going to take a look at the memory addresses that have been assigned to each of those modules that are plugged into these older OCSs. Now, to make sure that we do an effective job on our retrofit, it's important that we get as much information as we can about the original I/O modules. So go ahead and go to the Horner website, go to our documentation search page, you'll see the URL there on the screen, and find the cut sheets for the I/O modules that are used on the system. And that'll give you information on the specifications, current ratings, voltage ratings, all those sorts of things. Now, if for whatever reason you can't find the document on our website, if all else fails, just Google it. Take that part number information you pulled out of Cscape and Google that. There are a few manuals and cut sheets that we don't have a copy of that I was able to find on the web. We'll try and get that resolved. But again, if you don't find it on our website, you can just Google it. You'll probably find what you're looking for. So you've seen through the Cscape configuration what modules are there, and you've got now cut sheets on those modules. So you're ready, right? You know how much I/O you need. Well, not exactly. There's a trap here. And here's the trap. Just because a module is plugged in that supports X amount of I/O, it almost certainly does not mean that every I/O point is being utilized by that existing system. So there might be 40 or 50 I/O points plugged in from a module standpoint to the back of that OCS, but they may be using a fraction of those. So why replace all that I/O if it's just going to sit there and be unused? So what you really want to do is you want to see and examine in the program what's actually being used. And here's how you can best do that. Effectively, again, you're going to take a look at the real-world I/O addresses assigned to each of these modules that are plugged in, and then you're going to go to the element usage table. What is the element usage table? Well, it's basically a tool within Cscape that's accessible from the program menu that allows you to scroll through and find reference by reference what's actually been used in the program. So it won't show up there if there's a module plugged in that's assigned that address, but that's not actually used anywhere in the program. So this is how you can absolutely see what's really being used as opposed to just what's part of the standard module configuration for that particular module. So at this point, after you've taken a look at the element usage, you'll know by looking at the I's, Q's, AI's, and AQ's what I/O is actually used by this legacy system. Okay, then there's one more step from an I/O standpoint that we shouldn't forget about. Now, in a lot of systems they pretty much had I/O local there without remote I/O or without other I/O as part of the system. But that's not universally true. There were later on, especially, quite a few systems that were built where they expanded the I/O beyond what was plugged into the back. So there's a Cscan I/O tab you should take a look at. And if you find SmartSticks I/O on there, for instance, then no worries, because SmartSticks is not obsolete now, and it's not planned to go obsolete anytime soon. So you can continue to use any SmartSticks, for instance, that's configured with this older system. Also, what about any kind of remote SmartStack I/O that might be plugged into a remote control station RCS unit or plugged into a fiber optic expansion base? Those will need to be replaced because all those products are obsolete. So in those cases, you'll want to go back and find the memory addresses assigned to those particular modules, and then go back into the element usage table and look for those as well to see which of those was actually used. But in a lot of cases, I think what you'll find with machines is a lot of machines didn't utilize expansion I/O, so you can stick with what's built in. All right, so the final step of the I/O analysis really is by writing down all your list of all the I/O that you're going to need to utilize moving forward, effectively replacing it with new hardware and getting the addresses put into the system for the new system. So using a spreadsheet is really handy for this, and that's what we recommend that you do. In this case, you see on the screen here, I've got a list of digital inputs, digital outputs, and some analog points that were allocated for a retrofit project that I helped a customer through. Well, enough of these slides. Let's fire up Cscape here and let's take a look at what this looks like in real time when we're looking through one of these programs. So what I have here is a program that was developed back in, I think, around 2000 for a machine that utilized the OCS200 for doing some filling. And I've got that program here. So let's start with some of the steps I talked about, analyzing the I/O. So I'm pulling up the hardware configuration. You can see here's the OCS200 controller. I'm going to go under the local I/O tab. Here's the modules that were plugged into this legacy system. This is a high-speed counter. So keep in mind, high-speed counters are a little bit different. They have a lot of I's, Q's, AI's, and AQ's that are allocated to them, even though those don't all represent physical inputs and outputs. So again, this is a high-speed counter model, but this is all the different real-world I/O memory addresses that are allocated to it. And then the second module is just a 16-point DC output card. That's the only two modules in this particular system. Now I'm going to go back to the high-speed counter and dive in a little deeper here and take a look at the module setup. Now this particular case, they've got two 16-bit encoders that are plugged into the high-speed counter module, and they're using some built-in physical outputs on the high-speed counter to directly fire those based on encoder position. So that's what's going on in this particular case. So that's what we're seeing here with this high-speed counter implementation on this legacy product. So that's the I's, Q's, AI's, and AQ's that are assigned to those modules, but how many of those are actually being used? Well, that's where we go to the program element usage option here, and we start looking for real-world I/O references. And what we find is just a couple of AI references for the encoder accumulators. We don't find any I registers at all, so there's no just photo eyes or e-stop circuits or any of those sorts of things wired into regular old digital inputs, so we don't need to worry about that. Of course, we do have high-speed counting we'll have to take care of. And then if we go through and look for %Q outputs, we do find some of those. So if we count those up, we'll see we've got a dozen, an even dozen digital outputs that we're going to need to support moving forward. And that's a convenient number because there's a lot of OCS options these days with 12 digital outputs built into them. So anyway, that's our element usage for this particular system. So now we have a better handle on specifically what I/O is actually being used in this particular case. Now going back to our material, you'll see when I wrote down the list originally, there were some digital input bits that were part of the list. Well, this was actually from a expanded version of the machine. It wasn't this exact machine, but those particular inputs, even though those are all allocated or those are all assigned in the IO name section of this particular program, this machine, this exact machine, isn't using any of those. So that was important information that I wouldn't have found out except for going to the element usage screen. Okay, so now we've analyzed the I/O. Now it's time to select a replacement model OCS. And really, this is where you're going to have a lot of choices, right? You could choose a micro OCS unit. You could choose a XL series unit. You could choose an XLE or an XLT. There's going to be two factors in your decision, more than likely. One is going to be the I/O breakdown. What did I come up with in terms of how much I/O that I needed? So which of these product families is going to fit the best? But really the bigger question probably is, what size screen do I want? And if you're not 100% sure of that, really the best default option is the EXLW. So it's a great default choice for a couple of different reasons. Now, one reason it's a great choice is because physically it's about the right size. So it's about physically the same size as what the OCS100 and especially the OCS200 were. So if you've got an enclosure that's been sized for those products, the EXLW is going to fit pretty well. Now keep in mind, this is a product that has a 7-inch 800 by 480 screen in a fairly sleek package without any hard function keys or anything like that. So, and again, physically it's going to fit in about the right size. And it's also got a lot of options available because it is part of the XL series. And in my case, if I review what I needed here, the Model 3 with its 12 digital outputs and its high-speed counting capability is a really good fit here. So I'm going to choose, in this case, an EXLW Model 3. Now, I will say one thing about the kind of physical replacement of these older products with a newer EXLW. If at all possible, replace the door of the enclosure as part of the retrofit project. Why do that? Well, first of all, most enclosures, even really old ones, have replacement doors that are available for purchase by not even special order in a lot of cases, and you're going to end up with a really clean result and everything's just going to work better being properly mounted with a new door. So that would be the recommendation I would make if at all possible for a retrofit. Now, what happens if the list of I/O I came up with exceeded the I/O that's available directly in the back of one of the OCS models? Well, don't panic about that. You can add additional I/O to the system through one of our expansion I/O families, whether that's Smart Rail, Smart Block, Smart Sticks, whatever the case may be. Now, if you'd like a little bit of help in selecting one of these series, even though there really isn't a right answer or a wrong answer, we'll be more than happy to lend with that selection. And then one other note I will make is this, and that is that if you have AC inputs, and a lot of these older machines back in the day did use AC inputs, and you're not going to convert those over to DC, okay, so you're going to leave all the AC equipment the same, then we do have an opto-isolator accessory that mounts on DIN rail that takes up about the same amount of space as a field terminal block that can convert those AC input signals over to DC so they can be used with a modern OCS. I did want to mention that. Okay, we've talked about I/O pretty extensively because that was pretty important. We've selected our model. Now let's go back in and take a look at the user interface as it was basically implemented with the existing machine. Now, these products, again, they were text-based units and they had a pretty simple user interface. Most of the screens basically had text fields, they had data fields for displaying data for the operator. Some of those data fields were editable for anything that needed to be adjustable on the fly, you know, maybe a set point that had to be changed. And then there were also something called menu screens, which was just a little checkbox up to the right of that green configuration display for the 4-line display there. There was, again, menu screen option and alarm screen option. What are those? So a menu screen option would allow a user to implement kind of a simple menu for allowing the user to kind of navigate, kind of like an old iPod, if you will, to kind of navigate from screen to screen, set parameters, whatever the application required. And then alarm screens were screens that would only be displayed if they were forced by the ladder. So those were typically used to display diagnostics like, the door to the machine is open, the e-stop has been tripped, we're in over temperature condition, those sorts of things. So those were a couple of additional options in terms of the user interface implementation. And keep in mind, and I'll show you this on the physical unit we have here, keep in mind from navigating from screen to screen, most of the time, the user just used an arrow button to scroll from screen to screen. It wasn't very advanced at all. Now, some other things that we need to take a look at and need to take notes on are any data fields that are included on any of the screens, because they may contain important variable information that the user needs to know, and the editable ones may also need to be adjusted at runtime. So we want to make a note on those. And then we're going to look for any force decoils in our logic, which I'm showing you there in the lower right-hand corner of the screen, because those typically were used especially to enunciate alarm conditions by forcing a particular screen to be displayed in a certain machine condition. So we're going to want to pay attention and look for those, so those will give us some good clues in terms of how alarms were enunciated with that particular implementation of this older product. The last thing we're going to look for in the user interface area is any K bits or K contacts. Those are indicating the use of one of the function keys. Those could be used for today's functionality like screen jumps. They could be used to, again, force a certain screen, to be used as just an input into the system, whatever the case may be. So you're going to want to pay attention to those, and certainly for any function keys that were used as jump buttons, if you will, or even the ones that were used kind of as operator input, you're probably going to want to replace those with buttons on the touchscreen for the more modern unit that you replace this with. Okay, so before we jump on to making logic changes, let's head back into Cscape. And let's take a look at the user interface for my example retrofit here. So I'm going to go ahead and click on the screen editor icon. And this is where we see, instead of the graphics editor coming up, which we're all kind of used to in these days, instead what happens is this text display for the first screen number 1. Okay, and you see here we have descriptive text, we have data fields. These are live data fields that are filled in at runtime. There's an R at the beginning of each of these data fields, which indicates they're read-only. If we double click on a data field, we can see specifically which variable or which register is tied to that particular data field on the screen, what format it's in, how many digits it has, etc., etc. Okay, and whether or not it's editable or not. And then we also have this screen button here, which allows us to kind of navigate to all the pre-programmed screens that are available here. So, and then I can also utilize my simulation button here, I believe. Oh, nope, can't do that yet. That wasn't available yet. I'm used to all these new features. But I can go ahead and navigate from screen to screen the old-fashioned way. And you can see for these screens that have alarm screen checked, that means that the only way for these screens to come up is if they're forced by the ladder. But that's important because this screen is enunciating that the front center guard is open, and of course that can only or should only be displayed if it truly is open. So again, a number of these screens are considered alarm screens, so they have that checked. And then some screens are not alarm screens, so they can be navigated to with the arrow keys. And this particular one happens to contain a couple of editable data fields. You can see tied here. So again, this is the sort of information we're looking for as we're going through the user interface programming, understanding what data fields are important to the operator, maybe how the navigation was done in this original system, so that we at least have a handle for maybe some of what we're going to need to put into place with the new system. All right, let's head back to our material now, and we're going to move on to the next step. So the next step is logic changes. Now this is where we can really take advantage of all the existing logic that's been running so well in this machine for a number of years now. Instead of just having to start over again, we're going to take advantage of that logic moving forward. Now the first thing we're going to have to do though is we're almost certainly going to have to do some remapping. And that's because the SmartStack IO mapping points, the I's, the Q's, the AI's, and the AQ's, they're probably not going to match up in a one-to-one manner with the I, Q, AI, and AQ addresses for the replacement system. So what I'm going to do is I'm going to pull up that list of I/O that I had made in an earlier step, and I'm going to add a column. And now that I know I'm using an EXLW Model 3 in this case, I know what the new I/O addresses are going to be for each of these points that I'm going to be utilizing in my new system. Okay, so that's the first step. Get it documented what the old memory address location was and what the new one is going to be. Next, we're going to go back into Cscape. Now we're going to go to the new version of Cscape. Okay, so at this stage is when we opened our program, a copy of our program in a new version of Cscape starting at 9.9. And then we're going to start the process of finding and replacing the old memory addresses with the new memory addresses from our documentation we've just created. Once we've done that, we need to go back in and either using the IO names tool in Cscape or Microsoft Excel if we've got a bunch of them to do, then we need to fix the IO names and get those remapped as well. Because just changing in either the IO name tool or doing a find and replace is not going to change both the program coils as well as the IO name. So that's a separate step. This sounds a little complicated. It's actually not very difficult at all. Let me go ahead and demonstrate that for you right now. Okay, so in my new system here, all right, and I've opened this old program up in a new version of Cscape. In my new system here, I'm going to need to move my digital output starting at 41 to Q1, okay, because we're talking digital outputs here. So I'm going to go to the Edit and the Replace option here. And I'm going to look for, in my program, remember we're starting out with the old memory addresses, I'm going to look for Q41, and my new address I need to replace that with is Q1. And I'm always going to make sure Start from the top is checked, and I'm going to do a Replace All. And it comes back and tells me 4 occurrences have been replaced. Now I'm going to check that off my list and just go back one by one and replace all the ones that need to be replaced with their new addresses. And this is not difficult to do. You just need to do it carefully and save before you start this process, and then it'll go well. It's really a pretty straightforward process. Now, the next thing I need to do after I've done all of these is I need to go into my IO names, and I can either do this directly here in IO names or I can do it from Excel. And now I need to go in and fix the IO name. So I'm going to go find Q41 and I'm going to change the IO name to Q1. Now I'm going to do the same for the rest of these that I have already changed or already did my search and replace. I'm going to take care of that as well. Okay, so again, it's just a process of being diligent and not trying to do it too fast. And before you know it, you'll be done with all the remapping that you need to do. All right, so let's head back to our material and let's see what the next step is. So remapping is a step you have to be careful with, but it's really not all that difficult. The key is having good documentation, good notes to start with, and then checking them off as you go. So the next thing we're going to do from a logic perspective, we're just going to go through the logic. You know, even though we're going to end up reusing a lot of logic, it's still important that we do our best to understand what's going on in the program. Okay, you don't want to be troubleshooting a system where you have no understanding of the logic whatsoever. So hopefully the logic was at least relatively well documented, and now you can kind of go through the process of examining the logic and looking for things. Well, what are you looking for? Well, looking for anything that's obviously going to have to change substantially. For instance, if there's a bunch of logic that has to do with the high-speed counting, you might want to just take a look at that and make sure that the implementation of the new high-speed counter in the modern OCS, that same logic is going to work with the newer high-speed counter. That's one thing to look at. Also, you're going to look for any of those user interface type logic. If you decide that I'm probably going to use jump buttons to navigate from screen to screen, and I'm not going to use function keys for that, you can take a look and look for any kind of function key type logic or forcing type logic that ultimately you may want to either disable or just get rid of. Okay, so those are the sorts of things that you're looking for as you go through the logic. And let's just go ahead and hop back into Cscape, and I'll just show you a couple things in my program. Okay, so as I start at the beginning of the program and I scroll down through here, what am I looking for? Okay, so here's a couple of pieces of logic or a couple of rungs that have to do with forcing a particular screen to come up. In this case, we want to display this screen whenever function key 7 is pressed. So I have to kind of decide, all right, am I going to keep this sort of user interface, or am I just going to go ahead and probably get rid of that or disable it or something like that? So that's the sort of thing I'm looking for. As I scroll down, I can see down here, yep, here's some more logic that is forcing particular messages. Okay, and I believe what this is doing is walking the user through the setup procedure for the machine to start with. That's what's happening here. So that's something I'm going to have to either utilize as is or just replace. Okay, so those are some decisions I'll have to make, and that's the sort of thing that I'm looking for as I'm going down through this program. A lion's share of the logic, and I'm only going through a little part of it here, a lion's share of the logic is basically going to remain because it's mostly about machine sequencing, which doesn't really change. Let's take a look at what's next. Now that we've gone through the logic and we understand the changes that need to be made there, next we need to talk about the user interface design. And this is pretty much a blank sheet, really. You have the ability, remember in a previous step we went through and examined the current user interface implementation to get an idea of what variables were accessed, which ones need to be changeable, those sorts of things. But really we can spend either as much or as little time on the user interface as we want to in this step. We need to make decisions such as, do we want to take advantage of the more modern alarm handler? Do we want to use screen jumps instead of function keys? Those sorts of things. We've talked about that so far, and those are the sorts of decisions you're going to make, and then you're just going to go ahead and design the user interface as is appropriate. Let me go ahead and show you now just some of the decisions that I made, or I helped the customer make, when they went through and decided to create a more modern user interface for their machine. Even though they didn't want to spend a lot of time on it, what they were primarily interested in was getting the machine back up and running after retrofit very quickly, as well as making it so the machine didn't look like it was too difficult to operate for the operators that were familiar with the previous implementation. So I'm going to go ahead and go right to the user interface configuration here. And frankly, what I helped the customer implement was the bare minimum in terms of what could be done quickly and what could effectively end up with a quick implementation that was fairly easy for the customer to see. Okay, and this is where I'll go ahead and use the handy dandy navigation tool. So instead of function keys, we ended up with dedicated buttons for jumping to particular locations, jumping home, to an encoder display, to the current count, to the cycle count. Those are all functions that in the previous implementation, getting to those screens was a different approach, typically just with arrow keys. And then from a setup standpoint, this is where we went really simple. We just implemented arrow keys to jump them through the setup process for all the different parts of the machine that need to be set up initially. Okay, so again, very simple implementation here. You can see when I go to the matrix view here, these are all the screens that I ended up replacing. Now there are less screens here with the retrofit than there were in the original, and that's because I also implemented the alarm handler in the new EXLW to modernize that a bit. So a lot of those alarm type screens, those were eliminated because they weren't needed. We were able just to implement alarm handling instead. So that is just kind of a quick run through of this very simple user interface that we ended up with here. Now the next thing I want to do is just quickly summarize all these steps we've talked about. We need to acquire the program. We need to analyze our I/O requirements. We need to select a replacement. We need to analyze the existing user interface so we understand what variables are important, what need to be changed, how screens were navigated, just so we get a feel for that. We need to go in and make logic changes, starting with remapping our I/O addresses, which almost certainly will need to be done. We're going to change, delete, add logic as needed, going through the logic to understand it, as well as to prune areas that aren't needed anymore. And then we're going to go through and create our own newer user interface, putting either as much time or as little time as we've budgeted to make it way advanced and more modern, or to just get by with the bare minimum. And then one last thing before I bring Casey back in, I'm going to go ahead and show you just real quick what that looks like in runtime with the EXLW that I have here. So I'm going to set my OCS200 aside. Actually, before I do that, let me show you kind of the navigation that was done with the OCS200. You know, really it's just arrow keys, okay, moving to solenoid or to cycle counts and those sorts of things. Really rudimentary type navigation you have here. When you press function key 7, it moves you to a different screen, that sort of thing. So pretty rudimentary stuff. And again, we kept it simple on the EXLW as well, because that's what the customer wanted. So let me show that to you as well. Of course, we don't have any I/O that's actually updating here, because this is just, I just loaded the program and that's about it. But as you can see, we can navigate to the different main screens, and then we can walk through the setup process, navigating from setup screen to setup screen. Again, very simple stuff. Okay, so hopefully, as I prepare to bring Casey back in, hopefully that gives you a good idea on what we're talking about from the standpoint of the retrofit procedure for these original OCS units. Okay, Casey, anything I missed or anything that you think we should add?
Not in particular. I think we did pretty good coverage there, and no questions came in, or at least that I can see.
Very good. Now, some of you may have questions about, you know, I've got an older OCS, but it's a color touchscreen, or it's a monochrome touchscreen, or it's a monochrome display that's graphical based. We're going to be covering that in a future episode that's coming up real soon. We'll talk about that here in a minute. What I want to mention before I move on and say goodbye to Casey is, don't hesitate. If you're watching this on replay, give us your questions in the comment section. We'll get those answered just as soon as we can. All right, thanks, Casey. Remember, we're here every Tuesday at 2 o'clock with another technical topic. If we can be live, or if we have to pre-record, and this week we're fully live, we will be standing by, even if we're just streaming a pre-recorded recording, answering any questions you have as you chat them in. If you're watching on replay, you'll always have the opportunity to ask questions in the comment section. Next week is actually when we are going to get to that topic I just mentioned, and that is if you're talking about an older legacy OCS, but not a text-based unit, but one that's graphically based, what does the retrofit procedure look like for that? So a lot of it is very similar, so we're not going to cover all the same ground, but what we are going to do is spend more time talking about how you can reuse some of your graphics if you want to do that, and we're going to cover that in next week's show. Also, keep in mind, since we are at the beginning of the month now, we're into April, you can check our website and also check our April newsletter for all the rest of the topics that we'll be covering after we cover Retrofit Part 2. And one final thing, if you have not yet subscribed to our channel, it doesn't cost anything. Feel free to do so. It'll give you an opportunity to be notified if we go live or if we post another video. All right, once again, we thank you for joining us. We look forward to seeing you next Tuesday. Stay safe out there. Thanks.